So now let's check the next task, which is called trapping rainwater. It's a hard task, and let's check what we are given here. So we are given an array with heights, where height I is the height of a bar, and we need to find how much water accumulates after rain. And below we have an example where we have an array with some heights, and the output here should be 6. And below I have added an image in order it will be clear for you actually how the water is counted. Now let's go on and answer to some questions in order to better understand this task. So the first question, how much water sits on the top of a single bar? How does 2 pointers help here? And what pattern fits here? So let's answer to these questions. So how much water sits on the top of a single bar? So here we need to find the maximum height of a wall from the left side and maximum height of a wall from the right, and to determine the minimum one between these two, minimum height, because water is limited by the shortest side, because the water will pour out from the wall with smallest height. So next question, how does 2 pointers help here? So we track maximum left and maximum right. Actually it means the maximum height from the left and maximum height from the right as we go. Whichever side has the smaller max, we process that bar, because we already know the limiting height from that side. What pattern fits here? So actually here, in order to resolve this task, we can use 2 different approaches. We can use prefix-suffix technique, but in my case, I want to solve it using 2 pointers, because it's a little bit better than prefix and suffix. And the approach is that we will have 2 pointers left, which will start from the beginning of our array, and right, which will start from the end of our array. And moving toward each other, we will find a solution for the task. So now let's go on and try to implement this task. So let's start. So public static, and this method will return an int, because we want to know the count, the value of how much water will remain, so it will be an int. Let's call our method, let's say, find or let's say count trapping rain water, let's say rain water. Okay, and like argument we will have an array of integers which will represent our heights. So let's call it will be an array of integer, and let's call it container. Okay, cool. So we already decide that we will use 2 pointers here, so let's create them. Int left, which is equal to 0, because how we already mentioned that it will start from the beginning of our array, and int right will start from the end, so it will be container length -1. Cool. And also we will need 2 variables where we will store the maximum wall height from the left and maximum height wall from the right. So let's do it. Int max height from left, which is equal to 0 now, it will be initial value. And let's do the same but for right. Okay, I think it's enough. And now let's create a loop, because we will need to iterate through our container. Let's use while loop. And let's put here a condition that we want to iterate while left pointer remains less than the right. Why so? Because we don't want to compare same element with itself. So left always should be less than right. Okay. Now we want to decide where to move our counter. So what we need to move, left pointer or the right pointer. And for that we will need to check which height overall is less. Is less. So let's do it. Let's use an if statement and let's check which wall is less. So right less container, sorry, here should be left and right. Okay, which means that potentially we found the better height of a wall from the right side, and we potentially need to find the better height from the left. So we need to move the left counter. So let me show here you an example. So let's imagine that we are here. We know that our best height from the left is 2 and best height from the right is 3, which means that potentially we can find better height from the left. So we need to increase our left counter. So here is the logic. And in order to understand how much water can be positioned in this wall, we just need to take our maximum, let's say maximum height from the left, and because this height is less than this height, we make a simple calculation. So 2 minus 0 will be equal to 2, which means that in this wall we can put let's say 2 count of water, because the rest will be pour out, because the wall height is just 2. Okay, I hope you understand the logic. So now let's increase in that case the left counter. But also we will need to identify the maximum height from the left potential. So let's do it. Maximum height from the left is equal to maximum between our current one and the height of a wall on which we are now. Okay, and also let's calculate actually let's create another variable int which we will call maximum water trapped, let's say, which initially is equal to 0. So this variable will store how much water will remain after rain, and let's calculate it here. So which is equal to, how I already mentioned, we take minimum height between our maximum height from the left and right, and because now the height from the left is less than height from the right, it means that we need to take the maximum length over right, which means that we need to use our over left, sorry, not right. Maximum height from the left minus height overall on which we are now. Container left. Okay, nice. Okay, and now let's do the same but for right. So in case if the right wall is less or equal to wall from the left, in that case we need to identify the maximum height from the right, which is equal to maximum value between what we already store in maximum height from the right and current height. And let's actually here to do like this, so we need to add water, and here we also need to add water which can be stored on this wall. So let's do like this, and maximum height from the right minus current height. And here we will need to decrease our counter in order to move to the left. Right, minus minus. Okay, and now let's return our result. Return maximum water dropped. And let's check how this method is working. So public static void main system out println. Let's call our method count dropping rainwater, and here let's create a new array with these values. Okay, perfect. Let's check. Yes, so it's 6. So our solution is working. Now let's analyze our solution. So the time complexity is O(n) because each pointer moves at most n steps total, and the space complexity is O(1) because we have only 2 pointers and 2 variables for max left and max right. So I think that our solution is optimal, so we can leave it how it is. And also I congratulate you, because in the last 5 tasks we looked how to use 2 pointers technique in order to solve different tasks. So I wish you luck and thank you to watch my videos. Bye.